Very warm and exciting good morning to all my dear friends and students. Once again, I am with you with a very important area of the atomic structures. In the atomic structure, my main focus today will be on the quantum mechanics or the wave mechanical model of the atoms. Before I come exactly onto the wave mechanical model and explaining you the Schrodinger wave equation, I would like to take you back to the inceptions of the atomic structures, how exactly concept of the quantum mechanics came into existence. Way back in the year of 1808 or somewhere in between 1805 to 1808, the first scientist John Dalton gave a very fundamental concept that the smallest indivisible or indestructible part of a substance is called an atom. For so many years, like from 1808 until late of 19th century, this idea continued to hold ground, and the contemporary people or the contemporary scientists of that time also believed that the smallest indivisible part of a substance is an atom. But later on, in the early 20th century, this idea of atom no longer could hold or could continue to hold the ground due to sophistications of the techniques and inventions of new equipment. The so-called rudimentary idea of atom being indivisible part of a substance was rejected, like J.J. Thomson's, Rutherford, Chadwick, Goldstein, Niels Bohr. At different point of time in the early 20th century, they put forth the idea that atom is no longer indivisible or the smallest part of a substance. By the cathode ray experiment, canal ray experiment, radioactivity experiments, it was no doubt, undoubtedly proved out that atom is not the smallest indivisible part of the substance, but in turn is composed of tiny subatomic particles known as electrons, protons, and neutrons. Once it was discovered that atom is having electron, proton, and neutron inside it by the experimental evidence, it was later on postulated by the various scientists that how exactly these fundamental particles are situated inside an atom. In that regard, many atomic models were suggested. Some were very short of the primitive, holding no experimental ground. Some of the atomic models were really based on experimental evidence, like in the year 1905, J.J. Thomson was the first scientist who gave the very primitive atomic model, stating that atom is in the form of a positively charged sphere in which electrons are embedded just like the seeds in the watermelon. But in the later on phase, this idea was rejected because it could not support to the experimental outcomes of that time. So the very first atomic model, this model was rejected. Thomson's model was outrightly rejected. It could not explain the stability of atoms, how exactly positive and the negative charges are in the close contact. This idea didn't have any experimental ground and hence it was rejected out. Later on in the year 1911, the very first experimental model was presented by Rutherford. Germer and the Marsden, his two students, they did a series of experiments. The experiment is gold foil alpha particle scattering experiment. This experiment was the first of its time, which without any doubt proved that atom has a centrally situated positively charged nucleus in which whole of the mass of the atom is concentrated, and it is surrounded by electrons which are moving in a circular path, just like it happens in the solar system, that at the center there is sun and around it the planets are moving in the different orbits. This was the idea which was based on the experiment, but this idea of the Rutherford was also rejected just after 2 years due to its very drawbacks. Number first drawback was based on the Maxwell's theory of electromagnetic emissions, which states that whenever a charged particle is in accelerated motion in some external electrical field, in this case nucleus, the charged particle continue to emit out its energy in the form of electromagnetic waves, as a consequence of which the radius in which electron was moving will keep on decreasing, and by spiral motion finally the electrons will dump into the nucleus, leading to the destruction of the so-called atom. This was the first drawback, and the second drawback was that Rutherford's atomic model couldn't hold any ground or couldn't explain the spectra of atoms which came into existence of the Bohr's atomic models. Atoms exactly they have the line spectra, but according to the electromagnetic theory of wave, moving electron is continuously moving electromagnetic wave, and hence the spectrum of this should be continuous, but in case of atoms the spectrum found was discontinuous. So right after 2 years in 1913, Niels Bohr suggested, or he just postulated, his atomic model. It was not exactly based on the experiment because the experimental evidence was given only by the alpha particle scattering experiment. Some of the idea he took from the Rutherford's model and some other idea he incorporated based on Planck's quantum theory. So Bohr's atomic model was strictly based on Planck's quantum theory. Niels Bohr based his atomic model on the Planck's quantum theory and put forth some suggestions or some postulations, according to which atom has a centrally located positively charged nucleus surrounded by a circular path in which electron is moving. And in order to keep electron moving in the circular orbit, the necessary centripetal force and the centrifugal force need to remain balanced. The centripetal force came from the electrostatic force of attraction that is existing between electrons and the protons in the nucleus. This way, the stability of atom was explained. He also suggested that as long as electron moves in the circular orbit, the energy of electron remains quantized. Similarly, he also gave an idea that only those circular orbits can be mathematically allowed around the nucleus in which angular momentum of electron is quantized and is an integral multiple of h upon 2 pi. In order to explain for the line spectra obtained for the atoms, he suggested that the electron jumps from one orbit to another orbit by either absorbing energy or by just emitting out the energies. In nutshell, I can say that according to Bohr's atomic model, electron is moving around the nucleus in the circular path. It means to say that with respect to nucleus, we can precisely and exactly define the position and the velocity of the electrons, the energy of the electrons, the radius of the orbit, and these were some of the applications or some of the outcomes which were mathematically proved. So electron is having well-defined trajectory around the nucleus. Later on, there were certain drawbacks observed in the Bohr's atomic model, like it could not explain the idea suggested by the de Broglie scientist in 1924, according to whom electrons, like photons, have the dual natures. That is, it has got the particle nature as well as the wave nature. He based his idea on the Einstein's observations because Einstein believed that the light is got the particle nature as well as the wave nature. This idea was given by Einstein way back in 1905. So de Broglie just combined both these ideas of photons for the electrons, and he ultimately concluded an equation lambda is equal to h over p. P is equal to m into v. Yeah, lambda is equal to h upon mb. mb is representing to the particle nature of the electrons, and lambda is representing to the wave nature of the electrons. It means any particle having mass m, when it is moving with a certain velocity, that particle must be associated with a wave. So here from in the 1924 came the idea of wave nature of the electron as well. Before 1924, the idea was only about the particle nature of the electrons. Many phenomena like the black body radiation, photoelectric effect, they cannot be explained if we consider electron to be a wave. Interference, diffraction, many other optical phenomena, they are satisfactorily explained by considering electron to be a wave. And black body radiation and the photoelectric effect, these phenomena can only be explained if we consider electron to be of the particle nature. This wave and the particle duality led to the Heisenberg in the year 1927 to uncertainty principles. Very famous Heisenberg's uncertainty principle states that it is impossible to determine both position and velocity of a subatomic particle with a high precision with 100% accuracy. If we cannot find out the position and the velocity of electron with high precision, then it is completely baseless to say that electron is moving in a well-defined trajectory around the nucleus. Because if we know the exact trajectory of electrons around the nucleus, we can precisely say 100% with absolute accuracy about the velocity and the position of the electrons around the nucleus. So this very idea a well-defined circular orbit was ruled out in the light of the observations made by Heisenberg uncertainty principles. Now, up till this stage, there was a lot of chaos and the confusion regarding the atoms. So later on, idea of quantum mechanics of the or the wave mechanical model of atom was laid down by Erwin Schrödinger, who is the father of the quantum mechanics. According to Erwin Schrödinger, electron around the nucleus is just like a wave, just like a standing wave. Standing wave is the wave which is confined between two boundaries. In case of the atom, the boundaries are nucleus and the outermost cell. And electron is propagating, electron is present around the nucleus in the three-dimensional space in the form of the standing wave. Mathematically, by using the concept of the physics and the higher mathematics, Schrödinger was successful in obtaining a very important equation that is known as the Schrödinger equations. This is undoubtedly a very complicated equations. We are dealing with only the operational part of the equations, and when we bring this equation to some operational part, thereafter its solutions can be explained. So today my main focus is what exactly is the Schrödinger wave equations, how exactly the idea of considering electron to be a wave ultimately led to the conclusions regarding three-dimensional spaces around the nucleus, where we will define the probability of finding electrons. So let me get back to the board and make you understand how exactly, with the help of physics and the mathematics, this equation took form, and what exactly are the inferences ultimately out of these equations. Let's get back to the board and let us understand. In the Schrödinger wave equation, as normally we know in the physics in the simple harmonic motion, that y is equal to a sine omega t. This is a fundamental equation of wave. Here I have replaced y by the term psi. Equation is, y is equal to a sine omega t. In this case, as you must be having an idea that in case of the wave, this y represents to the amplitude, a is some constant, sine is a trigonometric function, omega is angular velocity, and t is the time. I have replaced this y by the term psi. Psi is the amplitude of electron wave. So psi is equal to A is some constant sine omega t. Omega angular velocity is 2 pi upon t. So psi is equal to A sine 2 pi upon the capital T. It is the time period. Capital T is the time period which a particle takes in completing one revolution. In case of the wave, if I am considering this to be a wave just like this is the psi amplitude from here to here. The time taken for one revolution is called the time period. Now suppose from here to here, small t is the time taken by the wave. Psi is equal to A sine 2 pi v upon lambda into t. This time period is the reciprocal of the frequency, and the frequency is related with the velocity by the expression nu is equal to v into lambda. I have substituted this value here in this expression. Velocity we know is equal to the distance traveled by time t. From here to here, if for example a wave is taking t times in traveling a distance, that is your x, so v is equal to x by t, so t is equal to x by v. That is what I have placed here. V to v, this gets cancelled out. Psi is equal to A sine 2 pi x over here lambda. By just crossing your v, I get this expressions. This is the wave equation that we also study in case of physics. Thereafter, I have differentiated the psi function with respect to your x. So del psi upon del x is equal to A. Its differentiation gives you cos 2 pi x over lambda into 2 pi over here lambda. So del psi upon del x is equal to 2 pi a upon lambda, and this function is cos 2 pi x over lambda. 2 pi a upon lambda, 2 pi a upon lambda, and this function cos 2 pi x over here lambda. Again, further differentiating it, this is the case of the double differentiations. Del square psi over del x square is equal to 2 pi a over lambda, and after the double differentiations, its differential will give you minus sine 2 pi x over lambda into 2 pi over lambda. This gives us del square psi upon del x square is equal to minus 4 pi square upon lambda square, and this is A sine 2 pi x over here lambda. We know that A sine 2 pi x over lambda, A sine 2 pi x over lambda is nothing but here psi. Psi is what? Psi is here the electron wave amplitude. If I replace this by psi, so I get expression del square psi upon del x square is equal to minus 4 pi square just upon lambda square into here psi. This is the equation of the electron wave in one direction, along x-axis, simply along the x-axis, because around the nucleus electron is in the three-dimensional space. If I take all x, y and the z axis, this expression in the three dimension can be represented del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square is equal to minus 4 pi square psi into 1 upon lambda square. Thereafter, what I have to do in this case, I will implement here lambda is equal to h divided by mb. Lambda is equal to h upon mb. It is the idea of the de Broglie equations. So del square psi upon this as a whole, it will become minus 4 pi square psi. Lambda, this is square of the lambda. Square of the lambda means h square upon m square v square. I have substituted the value of the lambda from here in this expression. The expression becomes like this: 4 pi square psi m square v square over h square. Again, we know that the electron's total energy is equal to kinetic energy plus its potential energy, half mv square plus u. Or if I try to find out here the kinetic energy half mv square, it will become E minus u. Calculating v square from here, v square will become 2 times total energy minus the potential energy divided by m. I can substitute this value of the v square in this expression, and after substituting the value of v square in this expression, I get del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square is equal to minus 4 pi square psi m square as usual upon h square, and instead of v I have represented this one 2 times E minus u upon, that is your m. 4 into 2 is equal to, that is minus 8 pi square. M to m cancels out, m to m gets cancelled out one times. It will get cancelled out. I have expression minus 8 pi square m E minus u into psi over here h square. Now I can just mathematically manipulate this way. From here to here, del square psi upon del x square plus del square psi upon del y square plus del square psi upon del z square. I have just brought this back on the left hand side. This sign will become plus 8 pi square m over h square multiplied by E minus b multiplied by psi is equal to 0. This way the equation has become psi. I have taken out del square upon del x square, del square upon this, or psi I have taken out here common, plus this is equal to 0. This entire functions, this entire thing is replaced by an operator. That operator is del square psi plus 8 pi square m over h square E minus u psi is equal to 0. This operator, in this case, this operator is called the Laplacian operator. This operator is called the Laplacian operator. Operators are just like in case of the mathematics. You take square root of 100 is equal to 10. So square root is here a mathematical operator. Similarly, in the quantum mechanics, this del square is an operator which is operating on the psi. How exactly this operator will work out, let me explain to you. इसको फिर आगे, after you know the del square psi plus 8 pi square m upon h square, I've just multiplied this inside with this energy terms, E psi minus 8 pi square m over h square u psi is equal to, that is 0. I am finding out the value of this energy in a function here, 8 pi square m upon h square into E psi is equal to, this I have just taken on the right hand side, minus del square psi plus 8 pi square m over h square u psi. This term, you know, this term here is represented as E psi. E psi, I am finding out the value of E psi is equal to this whole functions just divided by 8 pi square m upon h square. After solving this, I get this expressions, and in this expressions, this value yani E psi, let me write it again here, this is your E psi is equal to minus h square upon 8 pi square m into del square plus here u, and I have taken psi as a common factor here. Whatever you are observing inside the square bracket here, this is replaced by another operator that is called your h cap. This h cap is another operator, and this operator is called here the Hamiltonian operators. So E psi is equal to H psi is the ultimate equation that I have achieved here. I'm writing this expression here, that is H cap psi is equal to here E psi. It means when this operator, this is called here just the Hamiltonian operator, when this operator is applied on the wave function that is just psi, I get the energy function, or I get the energy of this wave function. If I get the energy, I find out the intensity. If I find out the intensity, I can just predict about the probability of finding electrons. Beyond this expression, when it is solved in the quantum mechanics, we get many complicated equations. This is expressed in terms of the spherical polar coordinate. Thereafter, the equation so obtained is fragmented into the three parts, one of which is the radial part of the wave function, the second one is the polar part of the wave function, and the third is azimuthal part of the wave functions. This was all about the Schrodinger wave equations, and thereafter, whatever we know, after solving these equations in the spherical polar coordinate, we obtain quantum numbers, that the principal quantum number n, azimuthal quantum number L, magnetic quantum number m, and we have many real and many imaginary solutions of the expressions, out of which the real solutions are accepted, and based on which we just predict about the atomic orbitals, their wave functions, their just wave function graphs, which are the wave function with respect to the radial distance, psi square with respect to the radial distance, and radial probability distribution function graph, from which we conclude out exactly how s orbital is spherical, how p is dumbbell, how d is in the form of just the two dumbbells. These are the things which I have explained in the previous videos, exactly what are the equations of the psi and how the manipulation of those wave equation is to be done. And next onwards, I will explain the graphs based on all these, and how the questions based on the wave function equations can be solved, what are the types of the question, how these questions are just related, and how exactly we just predict a lot of things about the quantum mechanical model of the atom. Thank you very, very much. And in the next upcoming videos, I'll be explaining the various facets of the quantum mechanical wave equations. Thank you.